All right, so let's figure out what we've got going here. We've got two events, A and B, and so I'm given the probability of A, but I'm only given the probability of B complement. So I have to think about what that's going to mean. So that means going to be the probability of B will be 1 minus the probability of B complement, right? Okay, so let's go figure out what we're being asked. So we're asked for probability of A or B, and I see there is an intersection. So I see probability of A or probability of B will be probability of A plus probability of B minus the probability of A and B. Okay, so probability of A I know is 0.6. They give me that. Probability of B will be, whoops, not plus, I meant not equals, plus 1 minus, I'm just going to put parentheses here, 1 minus 0.5, right? Because that's what this is, 1 minus the probability of B complement. And then I'm going to take away this 0.2, so that I get 0.6 plus 0.5 plus 0.2, I'm sorry, minus 0.2, minus, oops, minus, can't get rid of that, minus 0.2, which gives me 0.9. Okay, so let's play with some more probabilities. So I've got three outcomes, 0, 1, or 2. So these are the sets, A, B, and C. And the probability of A is 0.4, and probability of B is 0.3. Okay, so what will be the probability of A or B? Is there any intersection between these two sets? There is not. So that means you can have probability of A plus the probability of B, which will be 0.4 plus 0.3. Okay, so what is the probability of C? Well, probability of C, they don't give me, right? They don't tell me what the probability is. So I'm going to say that it's all, which 1 means probability of everything, subtract off the probability of A or B, because if A or B are happening, C is not happening. And so that gives me 1 minus 0.7 or 0.3. Okay, so probability of A or C, since they're independent events, that's just going to be the probability of A plus the probability of C, which gives me 0.4 plus 0.3, which is 0.7. And the probability of A complement, I want to make sure that you're feeling very comfortable with that. You know that's going to be 1 minus the probability of A, so that's 1 minus 0.4 or 0.6. All right, De Morgan's, it comes into play here, right? So I'm going to rewrite this as the probability of A union B all complemented, right here, right? Okay, that's going to be the same thing as saying 1 minus the probability of A or B, right? Using that complement, using this idea here, right, with this set. Okay, so let me just write it again. So probability of B complement would be 1 minus the probability of B, right? Just like this. So that's what I'm using here. So I know this is going to be 1 minus 0.7, so I get 0.3. All right, so using De Morgan's again here, so I get A and B complemented, which I know is 1 minus probability of A and B. And what's the probability of A and B happening? Well, it's nothing, because they can't, there's no intersection between the two of them. All right, and you have that one.